Yeah, welcome back to another session with your friend Edu Ada. Yeah, I'm sure you are going to enjoy this session, and we're going to be talking about refraction through convex and concave lenses. So we're talking about majorly lenses, and majorly we have the concave and the convex lens. Yes, and we're going to be considering the peculiarities in both of them, the major formula that binds them together. You, of course, let's talk about magnification. If you have magnification, you should know magnification is equal to what? Your image height over your object height, and that can also be equal to, call this height, and that can also be equal to what? Your image distance in meters over your object distance. So this is the relation you use for magnification. If you're solving anything that has to do with magnification of any object or the lens, and you have to deal with the distance of objects from either the PO camera, from the source, then the image formed, you relate it to this. The V is denoted by the image height and U as the object height, and that is also equal to the image distance from the camera and the object distance from the camera. You get? Now quickly, you should also know that your focal length is equal to 2 times your radius. Oh, sorry, it's half of radius of curvature. That implies that your R is 2f, where f is the focal length. And of course, your focal length is equal to your image distance times your object distance upon the image distance plus your object distance. We need these formulas in solving the questions that we have here with us. So let's get to the questions. Now we go. Let's start with the second question. An object is placed 24 centimeter from a converging lens. An object is placed 24 centimeter, that's U, 24 centimeter, from a converging lens of focal length 12 centimeter. Then what next? If a real image which is 2 centimeter high, the image height, I call it V subscript H, which is what, 2 centimeter high, what will be your, calculate the height of the object, UH, is what? X. Or I just put a question mark. Now, if we are to calculate our object height, recall from magnification that I said the image height over the object height is equal to the image distance. Okay, let me use small d. Image distance. Oh, the image distance upon the object distance. Do you get it? So I can call this height. V subscript H, U subscript H, equal to V subscript D over U subscript D. Here we have this. We equally have object distance. We have this, but we don't have this. We don't have this. So what do? We think we can easily get image distance from our focal length since we have our object distance. Are you thinking? Are you seeing the way I'm trying to figure out what we'll do to get our problem solved? So you look around the formulas that connect the parameters you have. You're able to think of, okay, yeah, this is how I go, this is how I go, and I get our answer done. So this is what we do. We go to F. Our focal length is equals to U times V upon U plus V, isn't it? So we use this, and our focal length is given as 12. So that implies that 12 should be equal to 24V, 24 times V upon what? 24 plus V. What do? On cross multiplication, you have 12 open bracket 24 plus V. That should be equal to 24V. Are you seeing that? So you do your multiplication. At multiplying, you are going to be dealing with what? You do your cross multiplication, then your multiplication. What comes out of that? What do you think we are going to be having when you expand that? At our expansion, we are looking at how we get the value. Yes, I mean the value of V, such that after getting V, we can go ahead to do other calculations. So you have 24 times 12. What do you have? We have 288 plus 12V, and that is equal to what? 24V. So what does that imply? That implies that what? Our 228 can be equal to what? 12V. By then you collect like terms. Divide both sides by 12. Then V can be equal to 288 divided by 12. So please, you can punch your calculator, and that becomes 24. So our image distance is 24 centimeter. So at getting that, what can we do? Let me write that here. V image distance subscript D (24 centimeter). So we go back to what we were doing here. We go ahead to calculate our image, our object height. So we go now, wipe this place, this, gone, 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 gone. So we can now say image height, which we don't. Okay, I think we have image height, that is 2 over image object height, which we are looking for, can be equal to image distance, which is now 24, divided by object distance 24. This and this, we have 1. Automatically What do we have? This implies our u will be equal to 2 centimeter. So our object distance is 2 centimeter. So quickly we go to question 2. What is question 2 saying? Under question 2, you have to calculate some things, and that deals with you have the converging length forms a real image of you have that. Okay, I think I may have to take this question under the next video. So thank you for staying with me.